I think we should again inform the participants because I think no one is live now. Yeah, they came.
I am Samir Sahu from Team SAR, and I am here to demonstrate the installation of Autodesk Fusion 360. As we have got a lot of responses to demonstrate the installation of Fusion 360. Now I will be demonstrating this feature, and by following which you will be easily accessing Autodesk Fusion 360 for free. So don't worry, I am here to provide you the demonstration as dilute as possible so that everyone present here will not have any issue in this regard. Okay, please go and check the comments. There will be a link of Autodesk Fusion 360 by clicking which you will be right on the Autodesk homepage. Okay, let me share the page screen. Is my screen is visible? Is my screen visible?
No, Samir, your screen is not visible. Yeah, yeah. You can carry on now. Go ahead.
Okay, thanks. Here you can see a blue button, get started mentioned over here. You can just click it out here. Then here you have to enter your country name. For my case, it is India. Here you have to enter your educational role, means you are student, educator, or whatever you are, you can enter it here. You have to enter your institution type. If you are in university student, you can click here at university, and here you can enter your date of birth. Then here you can click on next button. Here you have to give your first name.
Samir, I think there is some technical issues. Samir, can you hear me?
Yes.
Yeah, yeah. So I think there is some technical issues. I think we need to start from the beginning. So wait, just yeah. Can you start from the beginning?
From addressing.
Yeah, from the starting. How to
Good
from
evening.
clicking on the link to get started. Yeah,
Okay.
yeah,
Okay. Okay.
yeah. Go ahead.
Okay. First of all, click on the link that is provided in the comment box. Then you will be right on this page. Then click on this button, get started, and then you will be on its next page where you have to fill your country name, educational role, and institution type. Here you have to provide your country name. For my case, it is India. Here you have to provide your educational role. If you are a student or educator or whatever, you have to simply select. Then you have to choose your institution type. It is high school or university. You have to choose accordingly. Then you have to choose your date of birth. Then click on next button. Then here you have to enter your first name, then followed by second name. Then here you have to enter your email ID, and here you can confirm your email ID. Then you have to set your password here. Then you have to just click on I agree. You can also read the terms and condition and privacy statement of Autodesk. Here then you have to click on create account. Then a verification mail will be sent to your inbox. You can check it out. Then mm, then you can just click on verify mail. Then you will be verified. Then you have to give your educational institution name. For my case, it is Government College of Engineering, Keonjhar. Then you have to choose your enrolled from date, means from which date you have started your college life. And here you have to choose your graduation date, means in which date, which month and year your graduation will complete it. Then click on next button. Here you can see the here it is mentioned that your account is set. Then press and continue. Then here you can see this is showing my name, hi demo, because I have signed in with this name. Then you can click on again on this get started button. Here it will show you to confirm the details you have provided, that is correct or not. You can edit also, but if it is correct, then just click on confirm. Then here it will ask to upload your documents. You can prove college ID proof. You can give your college ID proof. It can be college I card, college receipt, or any other document in which your college name and your name is mentioned. Make sure that the document you are uploading is not more than 1 year old. Then just click here submit. It may take up to 48 hours to complete this procedure. So have patience and don't be panicked. Now we have come to the end of this demonstration session. Thank you.
So, hello, good evening, everyone. I am Vijay Pal, the host of today's session.
And I am Aman, today's co-host of the today's session, and I welcome you all to the day 2 of the beginner's guide to the Autodesk Fusion 360.
As we know, Fusion 360 is a cloud-based CAD/CAM tool for collaborative product development. It combines organic shape modeling, mechanical design, manufacturing in one comprehensive package. In this training session, students will get the basic knowledge about product design in Autodesk Fusion 360.
During the day 1 of this session, we got to learn through a lot of things, which I would like to take a summary of. First, we learned Fusion 360 is a CAD or CAMP-like tool. It is a cloud-based platform. In the workspace of the Fusion 360, there are many things, of which two of these were mainly focused, that are design and animation. For the designing purpose, there is a particular workspace, Fusion 360. Its icons show a line icons, surface icon, mirror icons, sketch dimension, concentric icon, and etc. There is also workspace for Fusion 360 of animation, and it also has many icons, of which two were fixed or unfixed icon and symmetric icon.
So, so thank you, Aman, for the summary. I hope this will help the students revise yesterday's session. Besides, today we are hosting the webinar on a new platform, and we need your support. And to make sure everything is going fine, what you can do is you can put up a thumbs up in the comment section so we can know that everything is going fine. Just guys, put a thumbs up if you can stream the things well, so we can know. Okay, great. Thank you. So, so space is a very vast field, and most of the students have the dream to pursue this. So here, on the behalf of Space Advancement and Research Cell, the official space club of Government College of Engineering, Kyonja, I would like to announce an initiative that we are taking to contribute at least our part in the development of this industry.
Carl's second quote, it states that all civilization become either spacefaring or extinct. Carl was an American astronomer, planetary scientist, cosmologist, astrophysicist, and astrobiologist, and also a science communicator. During an interview, he obsessed that life on Earth is soon going to be extinct, and to save humans from the flaws of nature, we need to continue for the search for our new home.
And today, through this platform, we want to take the initiative. We want to help those thousands of students who aspire to be a space scientist, who somebody gazed at the night sky and dreamed across the barriers of the earth, who we wanted to create a space enthusiastic society, the first of its kind. And so, to kickstart the firefighting journey, we wanted you all to join us. We want to be the torch bearers of SAR.
This society will mainly focus on sharing knowledge on a larger scale. We have less time and our goal being higher, we want to get started as early as possible. So, to help us in this initiative, I will be sharing you a Google form and only interested and enthusiastic people may fill it up. We're looking for people who want to contribute to space sector and want some of you guys to be in there.
So I will be sharing the Google Form link by filling which you can be the torch bearers of the next revolution and generation. So continuing with the day two of the session, we have with us Mr. Harsh Priyanshu as our expert trainer here. He is a college sophomore in aerospace engineering majors. Apart from that, he is an intern at Autodesk Fusion Catalyst, and he is also an very in the expert in the field of rocketry and astronomy. So it won't be wrong to say that astronautics and rocketry has been a passion for him since the time and beginning of the time. So thank you so much, Harsh, for joining our invitation and coming here for the webinar. So I would now like to request Mr. Harsh Priyanshu to start the webinar and enlighten us with the vastness of his knowledge.
Sure. For this lovely introduction again, I'll just share the screen.
Fine.
Okay, I hope the screen is visible to everyone. I'll just do a quick refresh of what we did. So, we discovered about some of the sketch commands which are available here. So there are various sketch commands where you can go and create new things. And after doing the sketch, if you want to modify your sketch, then you can use the modify command to modify using all these things. And then we have the constraint command. So constraint, it's up to you if you want to use this command or not, but it's not like very much of use. So if you are going for a very precise thing like a rocket or an aircraft or something, then you need to use all these things. But like if you are doing it just for a hobby, then you can go ahead with all these things. So don't need to go here. But if you have a very much experience, then I'm sure you will not be using this only. You can use this only. But the thing is, you need to be like practice this every day. Then only you'll get a hands on over the software. And then we saw some of the commands which are available inside the solid environment, or sorry, create environment. So which are all these things. So through after creating the sketch, you will be using all these commands to convert your 2D sketch into a 3D model. And then we saw some more modify commands for 3D. So these are modify commands which I discussed. And today I'll be showing you how you can use this surface command and these two assemble, construct and inspect commands. And then I'll be also showing you about the render, animation, simulation and drawing workbenches. So we covered all the major portions in the designing workbench. So I'll just show you how you can use this joint workbench. So joint is mainly used to create the motion links between two. So let's suppose I'm working on a mechanism, so which I want to move it and show it to my teachers. So I'm from aerospace, so we have a subject which is solid mechanics or aerospace structures. So these mechanical guys, I'm sure they will be having something, and I don't know what the other branches, but yeah, it's there. So I'll just quickly take a mechanism so that to show how you can add a motion to your objects. So I take a mechanism. It's 4 bar mechanisms. Four mechanism. You guys can search about it on internet. So it's just for I'm taking it just for examples. You guys can work with some more examples. So I'll choose for that. I'll choose a center slot. So and I'll make a slot like somewhere up to 200 and I'll just give it up to 25. And I need four of like this, and everyone will be like of different length. So again, I'll go to slot. I'll choose center to center slot, and with respect to this geometry, I'll make another with somewhat larger than this. So for this also, I'll give 25 only, and then I need two more. So for that, I'll choose center center again, and with respect to this, I'll draw something which is larger than these two. So this will work. 25. And one more. This one I'll keep it same. Okay. So I've created four bars here. So which you can see, it's the slot command. So through which I used to make the slots. So now I'll finish the sketch, and there I have my sketch, which is a 3D view now. So now first thing I'll do is I'll just convert all these 2D sketches into a 3D model. So for that I'll just go to extrude. I'll choose this and I'll give some extrude. I don't want very much, so I'll give it as 10 only. Okay. So I'll do same for all. I'll give it as 10. New component. Okay. So now I have my all components. So wait, I'll just extrude it everything at once. And okay, so I have my components now. But only thing is, as I have excluded everything like at once only, so it's showing me only one component. But if I could have done it separately, first this, then four more components will be there. So don't mind that. Just go here, click on the bodies. So all your four bodies will be visible here. So this will be your third. These are your four bodies. So what I'll do, I'll just right click on the bodies, and I'll click on create component from body. So this will create the component. This will convert the bodies into a component. So now you can do very much things here. So for to establish the links between the objects, so you need components, not the bodies. So you need to be very careful about the bodies and components. So first thing what I'll do is, it's a general rule for making any mechanism. You need to fix any one link, then only you can go for making another. So I'll just fix this link. It's the link to, it's highlighted here. So I'll right click on it, and I'll click on ground this link. So now this link is fixed. Even if I'll move this, and then this will not move, as we have grounded this, because we have fixed this link. So we can't fix this now. So as we have fixed this, it's became clear. Now we can attach links to our bodies. So just go to the joints, click on any one edge like this or this, and then go to the other side here and just click here. So now it will be attached to here. And if you will, we are here at the position. So if you will go to motion, you can see there are many joints available. So we have the rigid joint, we have the revolute joint, we have slider joint, we have cylindrical joint, we have pin slot, we have planar, and we have ball. Okay, so I don't want these all. I just want the revolute. So I'll choose the revolute option and I'll click OK. So now if I'll move this, it will easily move. And I can even animate this. So if I'll right click on it, animate model, then it will just move for me. So that's what we have to do for all these four links, and we need to combine them. So now what I'll do, I'll just again click on any link like this to here. So now it will come here. So we have done our next link also. So now you can see it will move like this. Okay. So now I have to just fix this link here. So for that also I'll repeat the same thing only. Just click on this and other side. It will be fixed there. Yeah, and lastly, I need to fix this with this. Choose this and this. Okay, so now we have fixed our all four joints. So now if I'll move anything, it will just move for me. So this is called the four bar mechanisms, where you will just fix one link and then you can move all with respect to others. So if I'll just animate the model, so now it will move for me. So that's how you can add motion to your objects in Fusion 360. So this motion is very useful. Suppose if you're working on some mechanism, let's say thrust vectoring. I hope you guys are familiar with the thrust vectoring. So thrust vectoring used in fighter aircrafts as well as in the your rockets for the maneuvering of the rockets and the aircraft. So there it's heavily used. So you can use this motion link to animate the links between in your model to check how it's moving. Then you can go for the 3D printing as well if it's working fine. So that's how this motion will work, and it's very important. If you will, it will take some time to learn as a and if you learn it, then it will be very good for you. So you can use this is the links one, and so this is about the joints part. You can edit this also. You can add like some screws here also to animate this. So as I have shown this just for the reference purpose, so I have not included those things. So you can add screws as well and everything. Then you can just animate it using this animate model command, and you'll be good to go. And you can also move it by hand also. You just need to click on it and you can just drag it everywhere. So as I'm moving it mouse, that's why it's not moving like smoothly. So you can do it. So this is about the joints part. So now I'll proceed to this construct and all. So before going to construct plane, I want to show you this thing. So here we have in inspect, under inspect, we have so many things. So first we have measure. So what measure will do, it will help you to measure the dimension of your model. So suppose I don't know what's the dimension of this. So I can click here, and so here it's showing length is around 324.673 millimeters. Now if I want to know the depth of it, so I can just click here and one time here, so it will show me around it is around 25 mm. So distance between these two points is 25 mm, which is our width. And and you can also identify the diameter or radius also. So just click that again and keep it on the circle, so on the arc. So here it will show you everything. With the radius here, it's 12.50 mm. The diameter is 25 mm. So that's how you can use this command. And then we have the interference command. Okay, with this we have the curvature analysis. So like you can see, it will show you that this using this you can analyze do the analysis of your curvature, so with the density and all. So you can use this command for the analysis purpose, and there are many more like zebra analysis. So you can perform this command also if, as you can see, there are no zebra kind of lines, so it shows like there are no faults in my geometry. So that's why it's not appearing here. Otherwise the model will be kind of full of zebra lines, like it's shown here. It will be like this. And then we have draft analysis. So this will show gradient color uh, to evaluate the manufacturability. Like using this you can evaluate how feasible will be your manufacturability. It will not show in this model. For that, I'll show you another model for this. I guess it will not show. Yeah. For that, I'll show you another model. So then we have curvature map analysis. So you can see it will map a color for your curvature, like it showed. It will show a color gradient on bodies to help you to analyze the area of high and low surface curvature. So it will measure where your surface is kind of thick or where it is thin. So you can use this. And then we have ISO curve and all. Leave this. Yeah, and using this you can evaluate what's your minimum radius. So you can use this all things, and then you can like use these things. And then we have Section analysis. Yeah, section analysis is very like good. So you can use this option to analyze in between the section, like what other if there are any defaults and all, you can just change it. So if you drag your mouse, you can see it will start showing me the section analysis of it. So you can like use it to analyze if there are any faults in the section. So you can do it, and it will just go like this, and it will again come back. So this is a section analysis. It's very much useful. You can use it in all your models. And then we have center of mass. So you can also calculate the center of mass using the Fusion 360. Only you just need to go here, center of mass, and then just click on OK. So it will show the center of mass for the model somewhere here. So you can use this. It's I guess it's not very much accurate, but you can like still just go ahead with other models and all. And then we have component color cycling toggle. So it will show me a color toggle for each component. So like you can see, it's now colored. It's also coming here. It's green, and then so you can like go ahead with this, and then you can animate your model. So this is about the inspect command, and now we have the surface command. So for the surface, I will like to I'll just switch to this create form environment. It's a completely different environment. So I'll show you how you can do it. So suppose I'm on a create form environment. For this, I'll not touch all these things. I'll just show you with the cylinder. So if I click on cylinder, then okay, wait. Before proceeding that, I will like show you how you can like design something. So to quick refresh or to a quick refresh of these things, and using these things, I'll just construct something. Suppose I'm working on creating a table or something. So firstly, I'll just click on the bottom plane. So I'll click on the bottom plane. I'll create the front portion of the wood or a table. So I'll I'll create it like this. It's arbitrary length. I'm taking it anything. So now if I'll finish the sketch, and then if I extrude it up to some limit. So this is the topmost plate of my table. So this is the table, and I want to make a drawer kind of something here, and in the bottom also. So I'll just again click on create sketch. I'll click here. So now I'm on the bottom plane again, and now I'll leave some margin to attach the legs for my table. It's I'm like doing a study table or something. So I'll use this here. So this is the margin for my legs. So I'll do the same on the other side also. Okay, this is the center one. So I'll choose mirror. Okay, I need a line. I have drawn a mirror line now. So this, and I'll choose this, and yeah. So this is a margin for me now. So I'll draw the drawer with respect to these margins only. So I'll start from somewhere here, and then I'll attach it here. So this I've drawn it now. So I'll just finish the sketch, and I'll extrude this up to some limit. So that's why I told like extrude is the very basic command to learn, and it will be used everywhere. So you need to learn extrude as much as possible. I'll just push it outwards. Yeah. And I want to make this thing hollow now. So for that, I'll choose shell command. I'll press this, and I'll give some as 5 mm or 6. Yeah, 6 will work. So it's hollow from inside now. Now I want to make the legs for my table. So to do that, again, just go to create sketch and start making your dimensions for your leg. So I want it to be square, 27 by 27, let's say. Same I want here also, 27 by 27. Same I'll repeat here also. And just one more last time. 27 by 27. So we have created our four sketches for our four legs, and I'll finish the sketch now, and I'll extrude all these up to some limit. Let's say 300 Till now 300, now 350. 350 will work for me. So now I'll okay. So I joined this. Just a second. I forgot to make this thing as a new component or body. Drag it 350. Now I'll just make it as body. So this is my table now. So now I'll make a drawer here, but first I'll just push this part somewhere outside. Yeah. And I'll attach two supporting bars here for the legs. So for that I'll just go here and I will draw some like rectangles here to make the supporting bars. And just I'll extrude this up to minus 27. Yeah, component. And I'll also mirror the same thing onto the other side as well. So just go to mirror, choose the component, choose this, and then choose the plane as right plane, and then it will be copied here like you can see. So we have done our 90, like not 90%, 80% of work. So with this example only, I'll be showing you about the render workbench also and the animation workbench, how you can use this after designing your model. So just like be very attentive, right? So now I'll make a small drawer here, which we can open and close. So for that, again, just go to create sketch, create on any plane. Like I want it here only. So just click here. And now I will make one dividing line here. Now I want my drawer to like be in this dimension. So it will be from here to here. Yeah, I'll take 3-point rectangle. So it will be here till here and here. I'll delete this. So this is my sketch for a drawer. So I'll just finish it and then I'll just extrude it up to some limit. What's the length for this? Right? Expect, yeah, I need to be length for this. Okay, so length is around 342.191 mm. So I'll extrude it up to same limit only. It's 342.91. Okay, it will work till here. And the distance is around now here to here it is 6.148 mm. So I'll add 6.14 mm here, which is 6.141. So we have created drawer till this line. So now I want to make a support here before proceeding to a drawer for the legs. So for that I'll just click here in this plate and I'll make a rectangle here. Uh, this will work for me. And I will just extrude this part and I'll join it here. Yeah, this will work for me. We have joined this bar also. Assume this as a supporting bar for me. So now I'll come back to my drawer part. So before that, I have to make a whole layer to insert my drawer inside. So for that, again, I'll go to shell command, give it a thickness of 5 or something. So it's the whole now. Now I'll insert my drawer. To do so, just take this back plane, which is here. So just now click on extrude and click on the back plane or the line and then extrude it up to the same limit only so that you can fit your drawer inside. Wait, I'll just 310, 35. I'll push this drawer part up to some limit so that we can attach the door also here for the drawer. So it's minus 10 now. So I'll just now extrude this part till here until it meets with the frame portion of it, and then click on new component, and then it's done. And then do one thing. Now create one door inside. So for that, click on any of these two. I'll click on this and just make a simple rectangle from here to here, and that's it. And now extrude it. So this will be the door for the drawer. Yeah, this will work for me and give it as new component. Now using this move and copy command, take your door out, 475, and this door also out, which was inside. So 475. Yeah. So now I have to make this thing using hollow using shell command. So choose shell 5. Now it looks like a draw now. So now I'll use the combine option to combine this body along with this body. So and I click OK. So now these two bodies have been combined. So you can now test it outside. Wait, it's not. Now it will combine. Yeah, now it's combined. So now I'll push this backwards only. Okay. So we have done our table. Now I'll make a small handle. So for that, I'll just go here in the create sketch. Before that, I'll just choose a construct pane, and then I'll click here, or let's say here, and then I'll keep it on the area where I want to make my handle. So let's suppose I want to make it here. So then click OK, and then go to create sketch, choose that plane, and I'm making a simple model, so I'll just use a simple arc. You guys can try it with some other things also. Like if you want to go for the more engineered or precise ones, so I'll just choose a simple arc, and I'll finish the sketch, and I'll just go here. I'll choose a pipe option, and I'll click on this, and it will just create something for me. So let's say 10. Yeah, 10 will work, and the new component, and I'll push this outside. Sorry, inside. There's no original way of doing it, so but I'm doing like it for just for the learning purpose. So like you guys can see, and you can try this out with. So we have, and one last thing, I'll just combine this handle with the draw, so that will just open it. So this is my draw now, like you can see. So before animating this, I'll just color it so that I can show you the render before going to the coloring part. So I'll just go to wood. I'll choose mahogany option here, and I'll make this also as wood only, and the draw portion as wood only, and this. Okay. Now I'll go to steel option. For the legs portion, I'll choose the cast steel, as they are mainly used for these things. So I'll use this only, and stainless steel cast. And now for the drawer also, I'll choose the stainless steel option. Polish option. Okay. So then, so this is a model now. If I'll change the view of it, so you can see we have the model now. So now I before proceeding to the render workbench, I'll just show you something like a good example for the rendering in this table only. I'll just choose the mid plane, and I will draw a glass or something like this. Uh, and I'll revolve this. It's very big, but it's okay. new component. So and now I'll just make it hollow. Okay. So now I will add some water inside to show you the correct demonstration of the rendering. So I'm using this glass and water example to show how exactly you can do it. And firstly, I'll make a same circle which is here. So I'll just click on this and then I'll create the sketch. Okay, wait, I have done some mistake. Component and then shell. We're good to go now. So just click. I'll just hide this first. I'll hide my table first. Now I'll do it. It's just the glass now. So I'll make it here, and this is my one circle. And then I'll finish the sketch now. I'll enable the sketches, and now I'll choose this construct plane option, and I'll draw one circle somewhere. Construction somewhere here. Yes, and I'll go to this, and I will make another row for the water, like the circle. So yeah. So now I'll hide this, and then I'll loft both. Component. So this is it now. And water. Yeah, it's looking like solid, but I'll add water effect to it. Don't worry. You can change the component name by double clicking on it. So now I'll enable everything except the construction. And now I'll color it in the glass color so that it will be easily visible. So I'll choose go here. I'll choose smooth glass window, and for this I'll just go down. I'll choose liquid, and then I'll choose water clear to color it like the water. So now I have now made it my model now. So firstly I'll show you without the glass of water. So I'll remove first it now. So now I'll just go to render workbench. It will take some time to load. It depends upon the processor speed, and when I close this sketch. So this is my render workbench now. So here you can control everything like how you want to project your model. So here you have appearance, which will be the same thing which we saw in that designing workbench, and then we have this scene settings. This is the main thing on in render settings. So here you can control everything from the environments to the light and all. So render is basically projecting your light from different angles. So that's what you can do from here. And then we have decal option here, so you can add your decals or something here if you want to. And then capture image, so you can capture the images from here. And then you have in canvas rendering. So I'll cover this after this. So this is the main rendering. So for this you need to save your design first. So I'll just save it as table. So it's saved now. You can do it by pressing control S. So now if I'll just press on the rendering option which is available here, so it will show me a prompt like this. So this is the main rendering. First, if you have the student version of Fusion, you don't need to be you don't need to worry about these things. But you have the license version of it, so then these credits will decrease every time. So for student version, it's free, so you can use it every time. So this cloud render, final render will take around 10 minutes as it's showing. But I don't want this much. I'll just go switch to local render and I'll switch to standard render. So it will do it for like lesser time, and then I click on render. So it will show me a local rendering started. So then it will come here. So as you can see, it has started now. It will take some time to do it. So till I'll cover the other portions. So if I'll change the angle and I'll open it. So I'll change the light settings. So firstly, you can see here we have the brightness option. So you can use it to increase or decrease the brightness. So I'll remain it like till here, and then we have this option which is the environment. So the currently selected environment is this photo booth, but you can choose anything from these things which is available here, or you can download your own also. These files are HDRI files. You will find all this in the net, so you can download and install it from the Fusion. So, and you can also find the that cloud HDRIs which will be available in Google. It's not available here, so you need to download it. So you can download it from there, and then you can use on your model. So currently I'm using this photo booth. So after photo booth, we have this option which is ground. So if I deselect this, you can see my ground has gone. So I'll choose this as we are keeping the table on the ground and then the flattening ground. So this will flat my ground for me to capture the image, and then we have the reflection. So if I enable this, our reflections will come. So I don't want this, I'll just deselect this. So now you can see we are on an environment, so which is the photo booth. It's exactly looks like a photo booth only. So this is it. And then we have the camera perspective. So you can go for orthographic also if you want. So for orthographic, it will look like this. And if you want to go for the perspective, so you can go for perspective as well. And this will control the focal length of your model. So it's all like the camera setting. So if you want to decrease the focal length, then your model will look like this. If you want a wide angle view of your model, so you can use this. And if you don't want the wide angle view, you can just keep on decreasing it until it becomes the orthographic. So I don't want this now. Currently, I am like I'll do it like this only. No, this only. I'll just and I'll also choose the solid color environment. Okay, so it's done now. And then we have the exposure. So this exposure will control the amount of light entering into your camera. It's like same the camera settings. You will find these things on the mobile as well. So if we'll decrease the exposure settings, it will control how much light is entering into your camera. So this like say, and then it's the depth of the field. So this will show a ray where your depth is there. You can just drag it anywhere. I'll just deselect this, and this is for the aspect ratio. So it depends upon like for what you are doing the rendering. So if you want a presentation, you can go for this and all. And then you have your default option, and I cover this. These are the environments. So to apply the environments, you just need to click anywhere. Like suppose I want this plaza one, so I'll just double click on it. It will take some seconds to load, and then it will come. See, now it will come. Wait for it. Yeah. So you can see we have the environment now. So I can control the light entering here. So I'll just decrease the exposure, and then you can see here. So I have many HDRIs. I have downloaded it. So I'll show you after the rendering of the model. For that now I'll just switch to photo booth only. 9.5. Yeah. So now as our original photo is being rendered, so I'll just choose this in canvas render to see how my model is getting rendered. I forgot. So this in canvas render will edit the model in the canvas only, so you can see how your model is getting rendered in the downward. So I'll choose this. Now the computer will perform some task for me, and it will just edit on what we are working on. So as you can see, there is one bar here, so it will like go for till the excellent one, and you can just drag it over the infinite or final ones also. So now your model will be rendered. So you can see how the beautiful model will look, and all your materials after it is being rendered. So that's how you can perform the render using this Fusion 360. And like it's very good. So you don't need to install like some other apps. Like there are 2 3 more apps like Keyshot and all. So if you want to go ahead with those, you can go ahead. But Fusion is also fine. You can go ahead with this also. And there are many wide range of HDRIs available. So you can go for HDRIs. There's one website which is hdriheaven.com. So you can go there and download the environments, and then you can use it on your models. So now you can see we have the in Canvas rendered model. So you can see like, that's how a model will look in original if you will like do it for real. And I'll just press it. And if I'll go downwards, you can see I have my model now. It's showing dark because like we didn't adjust the light settings. That's why it's showing dark. So no worries about that. So that's how. And if I click here, it will show me a prompt where I can download it. So you can download from here only. And if you look here, if you want a turntable view of your model, so you want your model to turn, so then you can use this option. It will take around 20 minutes to do it, and there are many frame options available. So to save the time, I'll go ahead with the 6 frames only, and I'll click render. So it will take now 20 minutes. So I'll just close it and I'll let it be rendered. So now you can add your decals also. So let's suppose decal will be your stickers and all. Suppose if you want to add some stickers here, any image you want to add. So I'll just show you an example. I'll open Paint and I'll give some random colors and I'll write like something or table only. I'll write okay, and I will save it in my desktop or somewhere, and I'll close it and I'll go to bottom view. And if I'll just click here in the decal option and then insert from my computer, then it will show me my it here, and then I can attach my decal anywhere. So as it's a paint image, so it will not look very much good, but you can go for attaching anything. So it will just come like this, and it will look good on your renders as well. So if you have seen my post, which I generally upload on LinkedIn, if you're following me, so I'm using these things like very much. So if you're working on something which is like already done by some other companies and you want to like just add up their logos, so you can do that by using this decal option. You can do that. Now I'll just enable my glass and water to show you how this glass will exactly look. So as now I'll just click on in canvas render. So now I'll wait for it till to get it over. So now you can see how well this rendering will look after you'll just render it. So this is my water which is here. You can see here, and this is the glass. As it's a water, so it will take some time to render as it's a heavy thing, so it will take some time to look. And with this you can get a clear view like how well this looks and how well the fusion renders. So you can like use it in your day-to-day life. And suppose if you have also modeled your model into some other software, then you can insert your model into fusion just for rendering also. So in this way also you can use fusion, and for simulation purpose also you can use. So it will take some time to do it, so I'll just stop it
I
here
think
only.
sorry to stop in between, but there are some doubts actually.
Yeah,
So
yeah,
yeah, what does exactly rendering option does? Anjana Priya.
yeah. So rendering will just like it will throw light on your model from different perspectives. So you can do it, and see rendering is basically like suppose you have worked on something, okay, and now you have to show that model to the other people like your faculty and all. So you want to show it to them. So then you can't show the model which is there, this design one. So you can't show it it's not looking very much good. So what people will do, people will go to this rendering. There are many softwares available also for this. It's a very important thing. So you need to show a rendered model to give them a clear view, like how your model will exactly look after it is being manufactured. And then, and if it's you are like going on for going on to find some manufacturers for your model, then it will be very much useful for it. So you need to show this to them how your model will look. So it's no use if you have designed it, if you have created the animation, you have done simulation, you have done everything, but your model is looking like this. So at no point they'll not accept it. Like they'll not have clear view of on what you are working on. So but if you'll show them something which which is a 3D model, and it's with the correct materials of what materials you will apply onto a model. So they'll have a clear view about on what you're working on. So they will be ready to fund you as well. So it's very important to use a render for a model and for competitions as well. If you're participating on design competitions and all, you need to show them, give them the rendered pics. So you need to like learn this. Can we go ahead with the next out?
Yeah. So next question is by Karan Singh. I have a doubt. Can you again show me that where you did the choose appearance command for applying material?
Hmm. For appearance command, I'll just show here only. So for appearance, you just need to press A from your keyboard. So which is A for appearance. Okay, so if you'll pay on your press A on your keyboard, this palette will come. So this is for the appearance, and here also it's same. So you can either just press A here, or you can go under modify. It will be available here. So that's how you can do it. And in render, it's available here only. So it's easy to find.
Uh, okay. Ishan has asked, can you show again where is the color option? I think that's the same question.
Yeah, yeah, same.
Okay, fine. Any more doubt, guys? You can ask now in the comment section.
Yeah.
Fine, Harsh. You can. I think you can continue.
Okay. So I showed about the rendering part. So now I'll move to animation. So for that, I'll try to animate this drawer to pull it outward. So I'll just push it out back only. Okay. So now I want to make an animation of my drawer coming out. Okay. So for that, I'll just switch to animation. And now I'm in my animation workbench. So I'll press this slider till here and I'll delete this. Okay. So now I'm on the animation workbench. So now I'll just zoom it. First, I'll just push it up to like some limit 10, and then I'll choose go to transform components, and I'll click on my drawer, and I'll drag it outside up to some limit. Okay, it's like 250. Okay, so now you can see a slider has changed. So now if I'll play it, you can see it's coming out. So, and one more thing, you can see it's coming out very slowly. Why? Because the slider is very long till here. So if I decrease the length of the slider by pressing here, and I'll just decrease it, and now one thing you'll see, the slider will come very fast as compared to the what we had earlier. And if I'll decrease it more, now it will come more faster. You can see. Okay, so I'll just go ahead with this speed only, and then I want to push it again back. So go to transform components again, click on the drawer and push it outwards, and then choose this grid transform command. So if it's very important to choose this command. If you will not choose this, then software will update on your existing command. So what will happen? Your animation will not be done, and it will show some error. So you need to choose this if you're animating the same component, and then press OK, and then we have it, and it's yeah. So I'll just drag it here for some gaps. So now if I'll go for the full screen and I'll press it, now you can see it's opening and it's closing. So that's how you can use this command to do anything. And I'll show for some circles also. Suppose you have a circle here, which has some circular pattern, circular pattern. This six. Suppose I have this, and I'll just let's suppose I have something like cylindrical. Now I want to rotate this. So how I'll do? First thing I can do is I can just use this joint option to rotate it. So how you can do? I'll show you. Uh, just choose this joint. Okay, it's fixed. We can't rotate like this. We need to go to animation. So I'll just go to animation, choose the front plane. I'll just you don't need to do this. I'm just like doing it to make it perspective for me. David. So now go to transform components. You need to do the same thing after coming here. Yeah. Okay. So now you can see it's been highlighted here. So if now I want to rotate it 360 degrees. So for that, I'll choose this slider. I'll rotate it. Now this option will come. So there I'll give either minus 360 or 360. Both of them will work. 360 for one revolution and 360 into 1000 or something like 5000 or something to rotate your model into 360 degree and up to 1000 times. So I'll not go for that. I'll just go for 360 only. So I'll just press this and then I'll just play it. You can see it's being rotating. So I'll just do it now only. So you can see it's rotating. So that's how you can use this command to either rotate to animate the single components, or you can do one more thing in this, like I have shown you in the presentation tomorrow yesterday. So you need to give an exploded view of how many components you have included in your model. So for that, just drag everything outside, everything like it's in 25. I'll drag it everything on same thing only. So I'll just minus 775. Okay, so now I'll leave everything as it is. So now I have done the exploded view. So how this will work, I'll show you. And now everything will be like this to give presentation viewers and some other people to have a view like how many components inside of the model you have worked on. So now I want to insert it again back. So now I'll give the same commands. You need to remember on how many lengths you have given. So slider will be here. Just click on split transform. Otherwise, it will be updated on your model only. So I don't want that. So I'll just give it somewhere like this, and then this I want to be back as it will be minus 775 as I pushed it on positive. So again, it will be negative now. So like some with some halt I want. So here and then this one minus 775. Click transform, and we are good to go now. Okay. So now see how it will do. It will just show you this will be your exploded view for your model. So you need to create something like this. It's not like looking very much good, but you need to create something like this to give people a view like how your things will look exactly from inside. So you need to show this to them. And next we have simulation workbench. So for simulation, I just switch. Okay. So for simulation, I'll just create a simple drawing, a simple rectangle. Uh, my rectangle now. So now I want to measure how much is the deformation. If I'll apply force from the upper side, I want to measure how well the deformation will come, how exactly the bending will occur. So I'll increase the size of it for the more bending. So now I'll just go to simulation, and to perform any simulation and stresses here, you need like a clear view about on what you're working for the stresses and all. So as you will like if you're developing something a rocket or something, you need to be very much sure about what the things are there. So you need to follow all those procedures. So here we have many things, but I'll just go for this thermal stress only, as it will cover both static and thermal as well, for static and thermal. But you can try all this, but to save time, I'll just cover the thermal stress. So I'll just create a study here. So we are on the simulation workbench now. So here we have things to simplify a model. So sometimes there will be some errors. So you can choose the simplify option to simplify a model. And then we have material. So you can change the material of your object to study how the deformation will come on the different materials. So you can see here, it's steel here currently. So but you can change it also. So we have glass and everything here. So you can do everything. If I'll go for glass and I'll press OK. So I have the glass now. Yeah, first I'll do with the metal bar only. So after this, I have the constraints. So what constraints will do, it's very important to fix either one or two ends before going on for the bending. Otherwise, the simulation will not occur. So I'll just go to constraints and I'll fix this portion. So it's fixed now, so nothing will occur in this side and deformation will occur here. So and then here we have loads. So structural loads, I want my deformation. I want to check how will the deformation will be from the upper surface. So just press here, and these arrows will come, and you can attach how much forces you want. So I want 500 newtons. I'll attach 500 newtons here. So 500 newton forces will come from here, and then we have the thermal loads. So we need to specify thermal loads also, as I selected the thermal stress. So I'll press here only, and I'll give it as 100 degrees. So we are done, and here we have the mesh. So to like for the engineers, it's very much important to have a same kind of mesh in your model. Otherwise, there will be some faulties in the simulation, and your simulation will not occur exactly. Like you can see, mesh is same. It's exact only. So like it should be same from everywhere. Then only it will come really well. So this is my forces, and if I go here, it will give a view. So it will show me, or this green will reflect it's fully fixed, and all colors are there. So and for thermal it's showing this is insulated very well, and we don't have any conducting surfaces here, so it's the conducting surface will turn green, and the things which will be free. If it's showing red, then you need to go for the simplify, then only simulation will occur. So coming to here, this is the manage, leave this. So you can see it's highlighted as tick. So if there will be some error, then a cross will come here. If not, then a tick will come. So you can do it. And then we have direct support for answers. So recently, Fusion has Autodesk collaborated with the answers. So they have a direct and here. So you can use the this option to directly import your model to answers for the other development. So you can answers very good software for simulation. So you can use answers as is more preferred, but Fusion also tells exactly the same thing except the stability answers. So for that, you need to choose answers only. So I'll just go for pre-check, and it shows all setup has been performed. So now I'll go for results and I'll press OK. So before doing anything, I need to save my model, otherwise it will not come. So I'll just save it, and this will come on cloud. It will require some credits, but I'll go for locally and I'll press solve. So now the software automatically build a study for me. Now you can see it's being done. So like wait for some times. The study is being done. Yeah, it's done now. So now you can see this is a deformation which is produced. Earlier a model was here, but now it's here. If I'll play the animation of it, you will understand more. So here you will be having animation. So you can play it and you can see how this is a deformation here. You can see when you have applied 500 newtons here. So this is the amount of deformation you are getting. So I'll play from here. So now you can see this is a deformation. So if you have the bar in real like this bar, and if you will apply the 500 newtons on that bar, this will be your deformation under the applied temperature. So this is a minimum and this is a maximum load case. So the maximum load case should be one. Otherwise, it will not be much. The simulation will not be good. So you need to be very careful with this. So, and this is the minimum load, and then you have leave this, and you have the compare option. So you can compare the two things. Like suppose this, you can, and you can do compare. Like you can see this is the animated view of it, and you can just compare it with the load produced here. So this is just for the comparison option, and you can add for layout as well to see from different perspectives. So you can animate anything, and then again this is for the mesh preview. And if I close this, I have again manage and inspect. So inspect will be the same things. It will just inspect your model, so you can try it. So this will hide your minimum and maximum, and this will create some surface probes like this. And I'll add this till here. So from here to here, it will create some grid points where you can perform your studies. Like suppose I want to perform my studies here and then here. So this will be useful when you are drafting a report, research report or something. On then you can study on what points, how much points are there. Like suppose in this point, how much is the load produced? In how much is the load produced? So you can try that if you're working for something, and then you have the reactions as well. So you can study the reactions here. So this is the forces which is active, entirely this is the force. Okay, 0 newtons. Okay, it's not coming exactly. I'll just go to create slice plane. Yeah, and this slice plane will do exactly the same thing for the section analysis. So you can just see how the things are looking inside. So there will be some cases when your deformation will be larger. So you can see this will not be as much as even as it is looking. So you can try it. And this is for the bar simulation. I will show you another simulation as well for the same thing only. I will just create again bar here, and I'll create two rectangles here. So this is called the simply supported beam. You can study about that. Earlier we did the cantilever beam. This is the cantilever beam. So there the one end will be fixed. It's the cantilever beam is the aircraft wing or the rocket fence. So they are supported from one end. From other end they are free. So this is called cantilever beam, and this is called the simply supported beam. So they are supported from both the ends. That's why they call it simply supported beams. And I'll just push it till here, and you got it. Okay. So and I'll increase this. I'll save it as I'll go to simulation. So, static stress only I'll choose. So for that now I have to fix my points first. Then only I can go for the deformation. So for that I need to first fix these two triangles. So go for constraints, fix this, fix everything which is there in the triangle, so that you will not get any deformation on the any side. And fix this. And now go for this, and this as well. That's okay. So we have fixed the sides now. Now we have to fix this side and this side as well, so that we will not have any deformation here. So now I just want this to bend in a curve. So for that, I'll just apply some load here. Suppose I'll apply 1000 newtons here. So we have done. Now it's showing correct, good to go. So I'll just press OK and wait for it to perform the study. showing the study. Yeah. So you can see it has came in exactly the same way like I wanted. So it is bending from this side, not from this side. So this is called a simply supported beam. It's very much important in aerospace industry to study about these type of beams. There are 3-4 types of beams which you need to study. So now, if I'll just play it, you can see how the deformation is produced under the 1000 Newton of the applied load. So you can try this all, and it's fun to use. So you can learn from these basic things, and then you can go for the advanced levels also. So this is about the simulation part. Now I'll tell you about the drawing part. Suppose you want to create a mechanical drawing from this part. So how you will do it? I'll just make few things here also to make it better. Uh, okay. So now I want to make a 2D drawing of this model to show it to someone. Okay, for that I'll just go here and I'll press go to the drawing, and now I'll click drawing from animation. Now this palette will come, so you need to click OK here. So now it will take me to the drawing workbench. So that's how your workbench looks like. So A4 sheet will come, and the model will come like this, and it will ask for you to specify the orientation. So I'll just give it as left, or not left, right. I'm not doing it isometric because if I do isometric, then there will be some dimension problem. So I'm not doing it. So and now I specify this ratio. 1:3. Okay. Now I'll just drag it in. So this is my model now. So if I'll press this and I'll press P from my keyboard, then I can just move it like this in any area. So I'll give one here and one isometric view. It's not coming very good. I'll delete this. Okay. This is the right view, this is the back view, and this is the isometric view of your model. So now there are some views to create your projected view from a model. It's the same thing which I showed you now. So you can either press the model and this option, or you can just press P also from your keyboard. And then again, you have create sketch here. So you can create your sketches like reference line and all. Like I want to create a reference line from here to here. So I can create this, but I don't want this now. You can use this option to create the sketches. But as I have already specified everything, so I don't need to create sketches now. You can use move option here to move it, or you can move it using by holding this also. So it will work for you. So and this is a geometry now. So if you want the center line, so this will show you the center line and all. This is a center line for this model, and it's already shown here. And this is a center line for this, and I showed for both. So this will be center line. This is for if you have some circular things, and this is the main thing. So if you will see, there are many things available. So first I'll go with the linear dimensions. So if I'll click on this edge and this edge, so it will show a dimension for me. So I'll just push it upwards and I'll press OK. So if I'll zoom in, you can see it's 840.52 mm. And if I'll click again here and I click for this, so it's this, and I want this dimension as well. So it's around this. Okay. So this is the dimensions. I'll just keep it short from here to here. Yeah, it's 840 mm. Okay. So that's how you can do it. And for here also, you can just go here, and give the dimensions. So that's it. It's that simple. You don't need to do anything. And this also. So if you're doing mechanical drawings, you need to specify each and every dimensions. Then only your thing will be considered. So this is the dimensions. And what more? So you have the align dimension. Let's suppose you have something which is on angle like this and this. So this will give the angle. I'll show you. I'll show the angular dimension first. So this and this. So the angle between these two is 90 degree. So like you can see, and the aligned dimensions. It's the same only. It will show for the align. And this is for radius. So if you have something circular or cylinder or something, so you can use this. And this is for baseline, which is this, and dimension break. You can break your dimensions using this. So I'd break. Okay. So it will break your dimension. Okay. So that's about this, and you can this option as well to create the dimension if you want something like better view. You can edit your dimension. Let's suppose I want it to be a 8 type. Okay, and here you have the text option. So if you want to write something, you can just press this and you can drag it, and then you can write whatever you want. Like suppose you want dimensions and press OK. So this will be it. Right? So you can drag it anywhere. It's suppose if you want to include a topic or something, so you can use this and okay. And this is the same thing. You can edit your sketches, the text using these things. And then here you have the symbols. Let's suppose you have something like for welding and all, there will be different symbols. You can use this, and for the datum for aircrafts and all, airspace, mainly for airspace, they are they will usually deal with the datum lines and all. So you can identify the datum line anywhere. So this is a datum line for me, and here this is, and there is table option available here. Suppose if you want to insert a table like this, so a table will come which will show the item quantity, part number, and all. So this will be useful if you are sending uh, uh, your product for the manufacturing part. It's suppose for the CNC machine or something. So there you need to give a detailed design drawing of your model with the correct dimensions for that 3D printing or for the laser cutting or something. So this drawing workbench will be very much useful for you. So this is about the table. You can delete this also, and this will show the same exactly the same thing. So you can it's like up to you. You can delete this as well. So table is done, and then we have the export option. So you can convert this into your PDF. So now I'll choose the desktop option available. So and I press yes, and it will be like saved into my desktop. So now I can like use it anytime I want. So if I'll go here and I'll press this that, so it will show me a PDF view of on what we have worked on. So this is about the drawing workbench. So guys, anyone has any questions, they can ask. Any questions if you have, you can ask. This software enables us to use programming language to design. Yeah, programming language you can use. They are like script add-ins. So I'm not showing you these things as it's mainly for the beginners. So if you search on YouTube, you'll find the code option available. So you can programming also design the elements, but it's more preferred to use the designing only. The which is available in Extrude to do it. So I guess it's only which hatch pattern, like where it is. Like I didn't understand about the hatch patterns. Like where is hatch patterns? I'll cover about that later. So I'll just proceed it. Okay, so like now as we have covered all this, so I'll now try to create something like I'll try to create a rocket. It's not up to like the aerospace scale. I'll just do it like as the fun model or for a hobby model. So uh, I have created a model in the Open Rocket. So like if you guys are like aware of the Open Rocket, so I have done it from there, and I'll just insert it into the Fusion. So I'll just click on insert, and I'll insert from my computers, and I've saved it. Yeah, it's here. So first I need to be careful about the properties of it. So what's the properties? So image property dimensions you need to check before going ahead. So it's 1872 by 547. So firstly, I need to create a center rectangle for that. So it's as it's shown 1872. You forgot that. It's 547. 1872. 547. 1872. Okay, so this is a model, but my image will come like this, not like this, because it's a rocket, so it should stand vertically. Now I'll insert it. Just go here and then click it. So now my image has been inserted inside the model in the Fusion. So now I'll just delete that, and from the edit canvas, I will just rotate it as 90 degrees, and now I'll push it upwards, and I'll make sure it should coincide with the line. So I'll give it as minus 40, 35. Yeah, this will work. So as you can see here, the rocket length is 42.5 centimeters. So and we are working on millimeter workspace. So either you can calculate that 45 centimeter into the millimeter, and then you can go ahead, or what you can do is you can just go here in the document settings. Here units will come, and if you click on change active units, your unit type will come, and here will be your units with the standard unit. So you can go for centimeter as well. I'll set as a default for some while, and now I will just create a line from here to here, 42.5. So 42.5. Okay, it will somewhere here. So now I have to create my this canvas up to these limits only. So for that, I will just click on canvas. I'll click on calibrate, and I'll press this edge and this edge, and here this palette will come. It's showing 187.34 centimeters, so I'll give it as 42.5. And now if I'll make a line from here to here, it will be exactly the same. So we have done this now, and I'll just move to further. I'll just drag it downwards. So again, it's now aligned, now not aligned with the center line. So I'll just align it with the center with canvas, and 0.5. Yeah, 0.4. So now I have to divide my rocket into 3 or 4 parts. So rocket has this body tube, inner body, centering rings, fins, and the cone section. And I'll not focus about this parachute and all, as we are working for fun model. So I'll just go for the outer sections only. So for that, first I will divide this line. So just go here and like this, and I'll divide this also. Now I will make a center line from here by following the green line. So it's not on the green. Yeah, it's now on the green line. So data parts I'll trim by pressing P. I'll trim this also, as we're going to use a revolve command for this. And I'll now make another line here and one more line till here. So I'll trim this. So we have created like a body tube part. So I'll exit from this sketch. I'll close the canvas. Oh, sorry, forgot to close this one. Yeah, now it's good. So now just go to revolve. Choose this option to revolve your body. So now you can see it's being revolved here. Now press OK. So now you can see clearly. And now I'll just hollow this part up to some limits. I'm not like if it's shown here, diameter is 2.5. So I will cut this as 1.5 centimeters. Okay. I'll again go back to millimeter and I'll choose the shell option. 2.5. 2.5 exactly I'll cut here. If I'll hide the canvas, you can see I have cut it 2.5. Forgot to cut here. I'll cut here also 2.5. Here. Okay. Yeah. Done now. Now I'll go for making the rocket cone. So first, what I'll do, I will make a small circle inside this. This will be the attaching point for my rocket to the cone point to the model. So for that, I'll go for like somewhere around 15 millimeters, and I'll push this downwards up for some time, and I'll go to the center plane to make the model. I'll repeat the same thing which I did for the body tube. I will make a line from the center again and choose this line option to start tracing the cone point. It's done now. Close this canvas I'll hide. Now if I'll go for revolve and then axis will be this. So any component. So my rocket cone has been formed here. So I name this as cone, and this is under body. So I'll create bodies. This is my body tube, and this one is my connector. So now if I'll hide the body tube for some time, it is like this. So I'll combine this. So this is for the one section. I'll not make this as hollow. I want it to be as filled. So I'll just enable this again. So we have created the body cone and this part. So now we have to create the inner tube. So to create the inner tube, it will be somewhere till here. So first just go back to the cylinder portion and just make a cylinder. Now I'll not do the shell portion again. So I'll just create the sketch like that only. So I'll create till 15. I don't want very much. So then press on extrude, and then with respect to a canvas, like that it's still here, and then choose for two sides, and then go up till here. So if I'll hide the body section, this is for the inner tube of my model. Okay, so this is the inner tube. Now you can see it's inserted inside. So now I'll make the centering rings. So I'll again convert it into the body. So this is my inner tube. Now I'll just hide this again to create the internal parts. So now if I see there is a centering ring available here. So for the centering ring, you can just simply use this was to create exactly here only. So use the plane option to create the cylinder up to till here. Okay, so I'll create here only. So just go and create and now enable it, and yes, your centering ring will be, yeah, somewhere it should be lesser than this. So I'll go till here. Okay, and one should touch this. So this is my ring now. I will extrude it upwards and I'll give it as new component, and I'll give it as ring 1, and one more ring is here. So I'll copy this upwards. So for that, just go to move and copy, choose this, choose create copy option, and just drag it upwards. Yeah, it will be there. So now again, so this will be my ring 2. Now if I hide my body section, you can see I had the canvas also. I have my centering ring now. Push it somewhere outside. Okay, so now I have to create the fence and engine for my model. Exactly the same. Okay. For to create the engines, I'll just adapt another way. First, I will the rockets have a convergent and divergent section of like the nozzles. So what I'll do, the model rockets don't have like this, but I'll make a convergent divergent section for it only. That's more easier to make. So I'll push it somewhere like 0 point. Okay, now I'll make a convergent divergent section. So go to that bottom portion of your model. First, we need to see where is the engine. So this till here we have our engine. From here to here, it's like coming. So for before making the convergence section, I will make another round section only inside till here, and I will extrude this upwards till here. Oh, it's kind of short, but no worries. And I will make this as hollow. Now here I'll attach my nozzle. Okay, one is here, and another one I can do is I need to choose the plate and I'll just push it somewhere outside. According to the canvas, I'll do till somewhere here I'll do with some margins I'm taking. So till here we have, and then I'll go here again, and I will just create another bigger circle like this. I'll do, yeah, and just close this plane. No, I don't need this. So it's drawn on the wrong plane. Again, I'll do. No worries. Yeah, we have this down. So I'll add the canvas and some sketches we have. I'll add those. I'll choose the one more circle. So now you can see we have two circles here, which is one is smaller, one is bigger. So go to lock, choose this and this. So it's coming like this, but I want it to be as convergent divergent. So choose direction and it will come like this. Choose new component. It's kind of very big. It's very big, but the more distance you will give, the more shorter it will be. So I'll leave it as it is only currently. So I'll give it as 5 mm, which I did the engine part, and if I'll inner molecule while enable, yeah. So now I will go for creating the fins part. So for fins, I'll not create the fin tabs as it's like we are not doing it for some professional purpose. So I'll enable the canvas again and right plane, and I'll just choose the right plane and I will draw it. That's not an airfoil. While drawing, I selected it for the basic square one only. So it's a basic one, not the airfoil. So I can draw it like this only. No need to go for airfoil. If you want to go for the airfoil also, then you can use the sweep option like I showed you like earlier. So you can do that. I'll show with the airfoil also after this way. And then just go here. And now you need to give some depth. So for that, I'll go for one by one. So 1 into 1, I'll give 1 millimeter here and then two sides 1 millimeter here. Use one new component. And this is my first fin. Fin one. And I will just mirror this fin to other part as well. So yeah, before doing that, if okay, let's designing will do after making this. So just go to mirror option, choose components, choose this, and then choose mirror plate, and then just mirror it here. So we have two planes, we have two here, but we need three fins. So for three pins, you just need to click on anyone as they will not come by mirror. I guess let's try. So yeah, by mirroring it's not coming. So you need to do it manually. So just click on this. You can create copy. Go to top and just revolve it up to 90 degrees and till here. So now go here and then attach. You need to do it very precisely, otherwise it will not match with your geometry. So you need to be careful here, and it should not coincide with this. So I'll just push it out. So and if let's suppose I want four fins, so I'll just mirror this component onto the other side. So we have got three bodies now. I'll just create the component from them. So this is our whole rocket now after doing everything. So we have the body tube, we have the centering cone, we have the nozzle and everything. So now I'll do some color coding here. So let's suppose I want it to be white till here and some other color from upwards. So what I will do, I will first make a line like this, no, somewhere till upward, like this, and I'll just finish the sketch and I'll choose this split face option to split for the color and point. I'll sorry scale. I'll choose this and I'll choose this. Reason for not choosing a split body option because it will just split your body and it will be unnecessary bodies here. So I don't want some more bodies as it will increase the weight. So I don't want to go with it. I'll just go ahead with this only. So now I'll just go for the appearance, which will come by pressing A from your keyboard. So now I'll add enamel colors here. So I'll choose glossy. No, sorry. As it's a face component, so you need to choose faces because we have split it on the face. So choose this, and then I'll choose black color. Uh, Putting black I'll take to create the black, and then no blue I'll take. Glossy blue I'll take here, and here I'll take white. White here. Okay, and for the fins also I'll give blue color only. And for this part, I'll remain it as like as it is it only, as it's not good to disturb this. I'll just give them black color. So we are done now. So this is a rocket. Suppose you want some fillet in these areas, so you can choose the fillet option to make it more aerodynamic. But then you need to do an all. I'll just show you with one. So it's 5.50, and you can make these all curves also. So let's suppose I want it to be as curve. So 1 millimeter I have taken, and now it's smoothen. So you need to do for same. So for all, so I'll choose all in once only, which is 5.50. And then I'll just choose all, and there we go. It's completed now. We have all the components which was there in the canvas, and it's not the best one, but you can do it. So if I'll try start hiding, so first cone section. So we have the body tube now, and then we have the connect this cone section, and then we have the inner tube, which is here. I'll close this. So we have the inner tube, and then we have the centering rings, and then we have the nozzle, and then we have everything. So I will just close this, and I'll just switch to render now to see how it is looking. So I'll just increase the length of it. So looking good. Now I'll just use some HDRIs to make this as more like looking good. So I'll just go for environment and it's looking like good only. I'll just go to environment. I have some external HDRIs, so I'll choose the cloud ones. If you don't have, you can download this. So I have like this much. So I'll search for the ones I'm looking for. Let's say So these HDRI files are, they are very big files. Somewhere it will be like, if you're looking for a 4K version, it will be like around 1 GB also. So you need to be like be very specific of what you want as it's loading. This is the last step, and everything is done now. I'll just decrease the ground plane. I'll decrease the exposure, and now you can see we are on the cloud. So this is the best way to demonstrate your aeronautical things or the aerospace things. So as you can see, as I decrease the light, as I increase the light, the sun ray becomes like more vibrant. So now you can see our model, how it is looking. So you can use this and you can change the material as well, and then you can start rendering. So that's how the Fusion 60 will help you to do all these things. You can do satellites and all. You can do everything. You can enable. You can also make the big rockets, but you need a blueprint, which will be easily available in the web, so you can use those. So I hope like it's a good session. So if anyone wants to ask something, they can ask.
Guys, if you have any doubt, you can ask your doubts here. Okay, fine. Uh, so I have just an announcement. So people who are just interested in SARC, they can fill out the joining form, and we would be really happy and glad to have you people on board. And next, as we promised about the certification, please fill up the feedback form we have shared in the group as well as in the comment section. So you're gonna fill it right now, and let us know your suggestions. So, after all, thank you so much, Mr. Harsh Priyansu, for such a wonderful training session. We are very glad that you took out your busy time for us, and also thank you to all the participants who have joined the stream. Team Sharks thank each and everyone who made this event a success. So, for the vote of thanks, I would like to call on Rahul.
Okay, good morning everyone. I am Rahul and I am here to present the vote of thanks for successful second day training session. I would like to thank our expert trainer Mr. Harsh Priyansu for accompanying and enlightening us with his knowledge. Today's training session was full of knowledge and interesting things. So today's session of demonstration in my opinion was very interesting and I am pretty sure the previous precious knowledge that he gave us will help us in our studies and future. So once again, I would like to thank Mr. Harsh Priyansu for taking such beautiful time from his busy schedule and enlightening us with his knowledge. So I would also like to thank our student committee for a smooth and successful ending. So stay home and stay safe in this COVID situation. And I would like to end my speech here. Thank you.
Thank you, Rahul. So, and thank you everyone for joining the session. I hope you might have loved it, and thank you, Harsh, very much for taking out your visit time again. I would like to thank you for your efforts that you did for us. Thank you.